Hello, everyone, and welcome to this Nordic webinar, How Cloud Helps Your IoT Devices to Get Location Data. For the agenda for this webinar for the next 60 minutes will be as follows. So basically, let's start with some practicalities and how this webinar actually works and how you actually also can enter questions. There will be Q&A session at the end, so we will actually try to tackle all of your questions and definitely will follow up if there's more than our time can handle. Couple of words about myself before we get started, and then also I have something to say about how technical support help works here at Nordic and the agenda itself. So we are talking about how cloud can help IoT devices to get the location data, and especially focusing on GPS and cell-based location information. Summary and takeaway will actually give you some ideas how actually you can continue with the topic also by yourself, and also finally what is the Nordic program for Mobile World Congress 21. So from practicalities perspective, the presentation itself will be around 45 minutes. We will have a Q&A at the end, and definitely I encourage everybody to enter your questions in the portal. So there's on the right hand side top, there's a questions box. Please enter your questions over there, and I'll try to tackle those at the end. And if there's something that is time won't allow us to answer all of them, we will definitely follow back. So something more about after this webinar, this is recorded and it will be available on demand on webinars.nordicsemi.com. So my name is Ville-Veikko Helppi. I'm a product manager here at Nordic. I joined Nordic last year, basically during the worst times of the COVID-19. But basically my role here is to look at the cloud side of things and cloud product, cloud solution that Nordic will actually offer for its customers. Past 16 plus years, I've been working in different product management roles. 8 of those, especially for the cloud products and software as a service engagements. Also some history and background with the embedded software, hardware, and tools around those. Also 3D UI graphics technologies have been something I've been looking at past 16 years. And time before I actually started doing the product management stuff, I've been doing engineering for the both software and hardware side of things. From community's perspective, so definitely the best source of information here at Nordic is or are these webinars that we are doing. So you can always go to nordicsemi.com/webinars and get the interest of your topic. Decent webinars, focusing on these topics. Of course, the developer zone, dev zone is always available 24/7. You can always enter your questions there and get answered. And if you're looking something more specific, there's also generic, section there that you can enter questions, for example, about the cloud and positioning, and our support will get back to you. Also from the source perspective, we provide this Nordic GitHub, so plenty of repos available for many of the programming languages. You can go to the github.com/Nordic Semiconductor and find repos over there. Okay, let's focus on today's topic. So how cloud helps your IoT devices to get the location data. This is probably something, people ask, like, why location services are needed. And definitely there are a lot of devices out there that location is a must to have, or the core functionality and feature of that device, like asset tracking, logistic transportation, even wearables and devices like that. Definitely many other verticals can also benefit from location services. So it's not only that those devices that actually need to have, or it's a vital or critical role of those devices to have the location data or information. There are other verticals also that can significantly benefit having a location on those devices. For example, like, devices that need to be tracked later on, where they were in specific time or so on. Of course, assisting data, providing information about location, very applicable to automotive and many other verticals as well. It's worth mentioning also that there are different solutions out there, different location technologies out there, and what we see here at Nordic is that when companies actually pick up something or they select some technology they actually want to rely with their devices, there's a good chance that they can increase their revenues and decrease also cost by offering something for their end customers, and also optimizing how that location information, assistant data or something is delivered on those devices. And when those location services actually come required, there are plenty of options out there that basically are defined by use cases. For example, like accuracy, how accurate you need that device to get the location. And also the other benefits, like how, for example, that location service can improve the battery life and power savings on that device. For some devices, it's crucial to be operable for the next 7 to 10 years even. And power savings, power life is very important in that. Also, what location services can provide is really fast and modern way to get that assistance or location information for those devices. So it's not only like improving these before mentioned topic things, but also like getting really fast that deliver data on those devices. And when combining different location services like from GPS to cell ID based location, basically switching technologies based on the use case or even while that device operates are possible with these kind of location services. Cloud, what I'm mostly focusing on this webinar, will actually provide and enable these kind of versatile use cases and can enhance device a lot. Of course, there's a lot of computing, memory, storage, and so on cloud side that can actually help that device to become better. Then, of course, typical question is what location service fits my use case? And in this kind of picture, I've divided these two dimensions, the position accuracy and power consumption in different levels. And it definitely depends on the use case. If we start with the unassisted GPS, like what is the most common way to use GPS on those devices? Of course, the trade-off is that it basically uses quite a lot of power out of the device. However, it will get you actually very good accuracy in terms of position accuracy. What is definitely the better option is this kind of assisted GPS, where you actually get something as provided as assistant binary or data for that device that can then make sure that you actually spend less power on that device, but still keeping the accuracy as good as it can get. Even better option could be predicted GPS, which actually saves you even more power, but still keeping the position accuracy as really good. And third option on the GPS side would be this kind of combination where you actually combine the assisted GPS and predictive GPS data in the device and use case. So in these technologies, assisted and predicted GPS, there's no compromise on the position accuracy, but the only thing you actually do is you can reserve power on that device to actually use it for other purposes. Another flavor of location service is this kind of cell ID based location service, where you actually can think single cell being something that gives you coarse location of that device. That is very power friendly. That actually gives you like zero power use. You actually get the coarse location of that device. Of course, the trade-off is that it's not highly accurate. How that accuracy can be improved is what we call multi-cell capability, where actually power consumption still keeps and stays low, but the position accuracy gets better. And of course, all these different options out there, they depend what is the use case on that device. If power is the top-notch thing you want to reserve, these cell ID-based location services probably work the best. If power is not necessarily the most important thing, but the accuracy is better or more important, basically GPS features will do the trick. How IoT devices typically get location nowadays. So of course, when device needs GPS data, it tries and goes to acquire satellite. Satellite sends ephemeris, almanacs, time-stamped information, and all those assets back to device. This is quite typical flow how GPS is used today in IoT devices. This, of course, is kind of takes a lot of time, and one of the trade-off is that time to first fix can be rather long. When it's long, it means GPS chip is on, and basically power is consumed all that time. And when that data is still delivered on that device, device basically still needs to process that for the GPS chip. Another example where actually devices are used to get the assistance and prediction information for those devices is kind of similar. When device needs assisted or predictive GPS data, there might be some third-party middle servers in the place that have actually GPS receivers, get the coordinates, and then basically process that on the device, on those servers. When that device actually is known, or the information is getting acquired from those satellites, basically then the data is sent back to device, and of course there's baseband and so on in the middle. Then GPS chip can actually work and get that, acquire those satellites. This of course takes quite a lot of time. It requires some infrastructure in the middle, and there are several bottlenecks and potential failure points when something can go wrong or something can get delayed, and this is why basically this is not necessarily the most efficient way to get the assistant data for the devices. Now we are focusing more on cloud and how cloud can help GPS. So a couple of kind of definitions for starters. So what we need for device is GPS receiver. And of course, the GPS receiver is something that is searching those satellites, looking at the situation on the sky, and then logs on those signals. Then it also receives the download and downloads that data that is coming from those devices, and then basically computes that location on that device for each satellite and get the exact location. What assistance can actually help is basically, of course, narrowing down which satellites are there and which satellites should be actually used, and what are their positions. So this is where assistance comes really handy and helps those GPS chips to be more functional and do the job more efficiently. What are the components for the assistance? So basically, when you actually have this kind of assisted GPS binary, you basically get the information about the date and time, meaning what is the exact time. Then it gives you rough location on the Earth, the position, and also this kind of approximate satellite orbits, also known as almanac. So basically, this is data that is good for some time for the future, and it basically is the same for satellites. This itself is not that accurate to compute a fix quickly. So basically more is needed to get the efficiency also for the GPS chip to be more efficient. Third or fourth item here is ephemerides. These are short ones, and they are only valid for like 4 hours and sometimes 6 hours. This is some data that actually can help you to get that GPS fix relatively quickly. Also, there is something else for GPS assistance like ionospheric correction and integrity data and so on that can be actually useful for the GPS chip to get the fix. So how assisted and predictive GPS actually works? So when this kind of situation application needs a GPS fix, it basically starts first the GPS. And then the modem on the device actually provides that cell tower ID information and the identification of that, and basically lists what kind of assisting components are needed. Then application sends that request to cloud that GPS assistance is needed, and basically cloud responds back with the assistant data. And finally, when that data is arrived on the device, application injects that assistance information to the modem. What we've actually done on NRF Cloud is this kind of service where we can actually make sure that devices using GPS chip can get very power-friendly assistance and prediction data for those devices. In this kind of example, so it goes basically the same, that device needs assisted or predicted GPS data. Basically, device goes and fetch those cell ID details. Basically, then it sends that data to the NRF cloud. And basically, what we do is getting this information together and reply and respond it back to device. And then device can rapidly acquire those satellites and actually determine where that device is. This is extremely fast method also to get the assistant and prediction information for those devices. And it's always, of course, accurate. And this kind of, when GPS chip is used, it definitely provides really good fit for multiple use cases. If you decide that you are going to use GPS chip on a device, this actually gives you a lot of different kind of versatile opportunities to use that data in different matter. And assisted GPS, predicted GPS, basically that is definitely something that both of these can be used on a runtime on the device. Also, one benefit of this approach is that you don't need to integrate multiple clients on that device. Basically, everything goes by the API, just asking from the API that assistant information is needed, and you will get that data delivered timely manner on your device. This is typical question, like our customers ask, like, what is the best, or what actually works the best for different kind of use cases? And we've been talking only like assisted GPS and predictive GPS now. So it would actually kind of be combination of these two factors. How frequently is cloud used, and how acceptable the use of cloud is. If you actually use it frequently, and you basically need some other data or some other communication, device management or something is ongoing, basically assisted GPS would probably be more efficient in that kind of use case. Then if cloud can be only used randomly every now and then, predicted GPS would be probably better, because it basically provides the data for up to 2 weeks. And that data can actually, the device itself also can be offline throughout that time. It doesn't have to send anything. And in that example, predictive GPS would be working better. So also combination of these two, like if cloud use is acceptable when available and when needed, assisted GPS, predictive GPS kind of combination would be also one option that could be actually used from the cloud perspective. Now, if we look at things from device perspective, if there's some constraints with the device, like very little or no flash, basically, GPS probably won't be a good option then. So then maybe cell-based location could be better. And it doesn't really matter whether it's assisted or predictive GPS. Basically, it's always the same. It's always the same data, always the same fix for that GPS chip. So it's only really matter of how long that data will be valid and how frequently actually you will actually use GPS chip to or want to get that data for that assistance. So definitely the choice impacts on the battery life. Also, of course, how much data will be sent between the cloud and device, and how many times GPS fix needs to be delivered on those devices. Basically, these factors determine what is the better, or what suits the use case the better, the assisted GPS or predictive GPS. That was assisted and predicted GPS in a nutshell. Now let's look at the cell-based location information and how this actually works on the cloud side of things. So single cell location, as mentioned, is really handy and good when you actually need a coarse location for that device. What we provide in NRF Cloud is this kind of simple lookup API you can actually use to get the information right away. What you only need to basically send to the cloud is the cell ID information, MNCs, MCCs, ECIs, and stuff like that, basically. And then by that information, we can determine where that actually device is and what are those latitude, longitude, accuracy value, and basically the coordinates of that device. Benefit, of course, single cell is that it is very, very power friendly method. It can be used to really to check the location, and if that location detail or accuracy is good enough, basically that can be actually help already the use case. But if more accurate tracking is needed, basically then probably multi-cell would be more preferable and recommended for this kind of example. For both single cell and multi-cell, the benefit is that basically they work also indoor and outdoor usage. So like with the GPS chip, you might see some difficulties on the indoor positions, but in the cell ID based location services, you basically can operate both indoor and outdoor. Downside of single cell maybe is that it doesn't give you that detailed accuracy. So we're talking about 1 kilometer roughly, and this equals like level of what part of the city is the device. In some use cases, and many of the use cases actually, it is just fine that that device is somewhere, and basically it's maybe it's on a move, so that it is actually doing something. But if more accuracy is needed, basically multi-cell would be then more recommended option. So multi-cell and this kind of neighboring cell tracking actually provide similar benefits as single cell. There is a bit more data that actually needs to be delivered. So it takes a bit more time to get that cell information. And there's very, very tiny power consumption add versus the single cell. However, it also works well on indoor and outdoor, so there's no difference basically between the single cell and multi-cell on this, and use cases where actually they can be used. So what the actually multi-cell capability is doing is it search for nearby cells on device, and this location accuracy is significantly better because it basically fetch information of those cell towers, and through this kind of triangulation calculates what is the actual location of that device. So in accuracy, we are talking significantly better. In this kind of estimation, it could be 300 meters. That already brings it down to level of street or building. So accuracy might be already good. And we're still talking about like really good feature what can be actually used on the device that doesn't add significant power consumption on this kind of equation. What we've done on location services on NRF Cloud, basically the flow goes the same way, that when device actually needs that information about device actually location needs to be figured out. Basically, it goes and fetches this kind of cell tower information, mobile country codes, mobile network codes, cell ID, and many other attributes like that. And basically that data is then sent to the NRF Cloud. That NRF Cloud basically utilizes this kind of cell tower database provided by third parties. We basically fetch that information, and then basically what can be done after that is send that position information to, for example, customer cloud for visualization. And what comes there as a response is latitude, longitude, also some accuracy value that is actually more vendor specific. And when we're talking about NRF Cloud actually providing this kind of capability and having third parties in use, we are actually working with multiple vendors globally to get the data for NRF Cloud. And basically what that data can do for Nordic devices out there, we are also picking up the best data that we know that works in different geographical areas, networks, and maybe some density use cases where actually that data must be the most accurate. So NRF Cloud really provides highly accurate information, and we compare that data that we are getting from different sources out there and make sure that the Nordic device gets the best value. This method, of course, as said, it's very power friendly. It doesn't take much power actually from device to fetch that information, send it to cloud. It's also extremely fast. You can get the location of the device very quickly. And its accuracy comes definitely from that fact that we are using multiple sources for the information. And as mentioned, cell ID based location services will work just well also for the indoor locations. All right, let's summarize and few takeaways also from here. So mentioned a few times, but of course comparison of these location features depends heavily on the use case. What is provided here are the 4 options called features also here. Assisted GPS provides you high accuracy, definitely good power savings, but still requiring that GPS on the device. Assisted GPS is really handy for many of the cases where you actually communicate frequently with the cloud, or you need some data to be stored somewhere. And basically that can enable that binary sent back to device can enable faster time to first fix for that GPS modem. Predicted GPS provides the similar kind of accuracy. The data itself is the same, but power savings are better as you can actually download more data on one shot, and basically that data is even valid up to 2 weeks. So even device goes offline, it doesn't do much. Basically, still the GPS chip can be used, and basically based on this data that is sent with the predicted assistant data, it can operate that 2 weeks and get the time to first fix quickly for the GPS modem. Then this single cell, basically, as mentioned, it's really handy, quick to get the kind of coarse location for the device. It gives you really good power savings because you don't consume power at all. It doesn't require GPS, and basically, for many of the use cases, this is just good enough, basically for the understanding where approximate location that device is. And finally, the multi-cell, which adds something for the accuracy, gives you better accuracy in a way that you can get that street or level gratitude for the accuracy, still keeping power savings high. So GPS chip is not used. You basically get everything delivered to you very efficiently, and no GPS chip is needed. So these are the different options for the features. Of course, I said, it really depends on the use case, and it really depends what, how long that device should operate with the battery. Can that device be charged at some point? Is the GPS chip use acceptable? And also what other connectivity methods and this kind of connectivity, for example, with cloud, is acceptable. So these kind of factors determine what actually fits the use case the best. Something about the options for how clouds typically operate and what are the cloud transports. We are defining these in 2 kind of categories. When we're saying device to cloud, that means basically device itself connects directly to the cloud, and basically that device maintains this kind of bidirectional connection with the cloud. Whatever data is sent between these 2 entities, also basically the location data will go the same data pipeline. Another approach is this kind of cloud to cloud, basically where customer clouds or other cloud setups can be in the middle. NRF Cloud in that kind of example would be serving as an infrastructure or service cloud, where it actually provides that data to the other cloud, and basically that other cloud connects and communicates and handles all connectivity to that device. This kind of option, of course, provides greater flexibility, and also the control of those device communication workflow is more enhanced. It basically provides also the more streamlined connectivity approach for those devices, as only one connectivity for device is required. So you don't need to connect IoT device to multiple clouds, but one cloud will do all of the serving of those data. There's a tons of use cases we could actually go through and see how cloud can provide and what cloud can actually provide for those IoT devices. Of course, this kind of detailed, accurate, and fast location service for IoT devices is typically something you get through these location services. And one of the greatest benefit of using location services is that you can use different technologies in different situations with that device. So in certain situations, you might need accuracy and you might need more detailed location information. GPS usage would be then acceptable and probably the best approach. But if you need only like course location and not that detailed latitude, longitude coordinates, cell ID based could be also an option. And these technologies and these different kind of features can be combined. So let's say, as an example, you have trucks on a road. Maybe it's just fine if you actually use single cell location when it's on a move. When that truck comes to the warehouse and you basically need detailed accuracy, you might consider using multi-cell for indoor location. And if that location is something that GPS chip could also handle and can actually provide you a fix quickly, also GPS is something that you can be used in this kind of combo. Also, what cloud provides in these kind of examples, of course, mention that, in the cloud, you can see from the device perspective that there's endless resources for computing, storage, memory, and so on. So basically, utilization of the cloud for all those kind of assets that needs to be stored about the device. So for example, historic location of the device. You can go back in time. You can search where that device was on a particular moment, or you can actually optimize the routes. You can actually do some logistical enhancements for that device. So everything based on the data that is stored where that device was should be and could be done on a cloud. And when you have this kind of data available, of course, it's easy to also do some analytics for this data, how those things can be actually optimized. And for example, like, also build more logic around the application, like predicting when certain goods will be in certain place, if we use this transportation as an example, or certain parameters from that device. For example, if you have a asset tracker, or let's rather call pet tracker, and if other sensor values from that device are giving you, for example, like high temperature, you might know that your pet is actually in some hot location, and some other alerts needs to be sent. And that's exactly where the cloud can also provide additional help. Combining these kind of different sensor data to location information, and also combining that with how you manage those devices actually will provide a lot of value for those IoT use cases. Definitely location services combined with the IoT device management capabilities and other useful features are always recommended. There's a tons of options out there. What is currently provided from NRF Cloud are basic capabilities to update and maintain the device. If you log into nrfcloud.com, you might find there something useful, building blocks for your own device management, or even utilizing those as they are as part of the location services. All right, so get on it. Basically, we have more webinars actually coming, and always, you can find these webinars on webinarsnordicsemi.com, and also, of course, the tech support and any community information can be found on devzone.nordicsemi.com, and more information about the products and services can be found at nordicsemi.com. One more thing before we go into the Q&A. So we are actually having one more webinar in this Mobile World Congress series tomorrow. Exciting new features in NRF Connect SDK 1.6. Highly recommend that you also participate here. We actually have two sessions for tomorrow, so take a better time and definitely join the webinar tomorrow. All right, let's move to the Q&A. There's a question about